Chapter 4.3 exercises 1 through 12, and we're going to go over, we hope, all the odd-numbered problems, 1 through 12. With exercise 1 and 2, identify the one angle that is not coterminal with all the others. And so this really calls for our understanding of this piece of vocabulary, which may be new to you, called coterminal. Okay, terminal means end. Okay, I'll just write it. Terminal equals end or ending, right? In coterminal means co-ending, or angles that end in the same place. Well, to understand the way angles work, when you start out in a standard conventional circle, they're starting out here at an angle of 0 degrees, 0 radians, and what you're doing is you're rotating. The positive rotations are going to go counterclockwise here, and the negative rotations are going to go clockwise. So let's go ahead and evaluate and see which one of these is not coterminal. So of these 5 angles, one is not coterminal, all the rest are. So let's do the analysis. 150 degrees. Well, we know if we come straight across here, a half circle, this would be 180 degrees. And 150 degrees would be right here, which is going to be 30 degrees less than 180. And 510 degrees is going to be come all the way around here, 360. So to find 510 degrees, where that ends, we have to take 510 degrees minus 360, and if we go ahead and subtract that out, we get 0. We get 11 minus 6 is 5. We cancel that 5 here to be 4, so we have 4 minus 3 is 150. So what that tells us is that a 510 degree angle is going to be this 360 degrees plus another 150, or this 150 degrees plus another 360. So we know that neither of these can be a right answer, since both of these are coterminal with each other. Next, negative 210 degrees. Let's I want to clean this up a little bit just to allow us writing room here. Okay, there's that cleaned up a little bit anyway. Okay, negative 210 degrees is going this way, and here we have negative 180 degrees, and another 30 gets us to negative 210, which gets us to the same place as our original 150 degree angle. That is not correct. Now 450 is, for 450, that looks like it might be interesting, because if we take 450 minus a full circle rotation of 360, 450 minus 360 equals 90. And so a 450 degree angle would be once around like this, plus another 90 degrees. And so the terminal side of this 450 degree angle is right here, which is not consistent with the first 3 that we looked at. So this would have to be our correct answer. And just to fill this out for 870 degrees, if we take 870 minus 360, we're going to get 0, that's 1, 5, so we're going to get 510 degrees. If we subtract another 360 from 510 degrees, we get 150. So 150 degrees. So 870 degree angle rotates around twice, plus up to 150, so that is not coterminal. So anyway, 450 degrees is our correct answer. Let's go on to problem 3. In exercise 3.6, evaluate the 6 trigonometric functions of the angle theta. I like to call them ratios instead of functions for some reason. Anyway, here, most of the time we've been examining the sines, cosines, tangents, etc. within the 0 to 90 degrees. In this case, we're coming over, rotating beyond in quadrant 2. So in this case, we have a just kind of expanding, make a drawing that expands. We have this thing here where we have a point at -1, comma 2. So here at -1, comma 2, we have a triangle, and to find what it looks like, we're going to draw right from the origin and go straight down to the x-axis. And our angle is going to be really, what this happens, we have a cosine. This -1 means that our adjacent side of this triangle is going to equal -1. And this 2 that goes up is our opposite side, which equals 2. And our hypotenuse is going to be, if we take, we're going to have the square root of -1 squared plus 2 squared, and that's going to be square root of 5. So our hypotenuse equals square root of 5. So sine is going to be opposite over hypotenuse, and opposite is going to be 2 over hypotenuse, which is 2 square root of 5. If we wanted to rationalize this, multiplying numerator and denominator by square root of 5, we're going to equal 2 square root of 5 over 5. Either of these are correct answers. So I'll just box this in. So that's our sine. And what is our cosecant going to be? It's going to be square root of 5 over 2. So our cosecant. Our cosine theta is going to be this value, x value, -1 over square root of 5, which rationalized equals, multiply the numerator and denominator by square root of 5. We're going to have negative square root of 5 over 5. That's our cosine. Our cosecant, our secant is going to be the reciprocal of over square root of 5, which is going to be just negative square root of 5. Okay, so that's our secant. We have our cosine is negative square root of 5 over 5. And the last thing we're going to look at is tangent. Okay, tangent theta is going to be opposite, and our opposite is going to be this 2 over -1, which equals -2, and the cotangent theta equals, instead of 2 over -1, we have -1 over 2. So that would be our answer to problem number 3. Next, problem 5 find the trig trigonometric functions. Again, this time we have -1, comma -1. So we have, in this case, our adjacent is going to be -1, and our opposite also is going to be -1. So our we can just figure out our tangent. Tangent theta equals opposite over adjacent, which equals -1 over 1, -1, which equals 1. So that's our tangent theta, and our cotangent theta is reciprocal of tangent, which is also going to be -1 over 1, which is 1. Now sine is going to be opposite, and opposite is going to be -1 over, what is this hypotenuse here? Hypotenuse is going to be if we work this out, we're going to get square root of 2. So sine theta is -1 over square root of 2, which rationalized is going to be negative square root of 2 over 2. And the cosecant is going to be reciprocal of -1 over square root of 2, so that's going to be negative square root of 2. And then our cosine theta is going to be the same as sine -2 over, let's see, rationalize, we multiply the numerator and denominator. So we'll get negative square root of 2 over 2, which is the same as sine, and our secant theta is going to be our reciprocal of, which will be negative square root of 2. So here we have secant, cosecant, cosine, sine, okay. Problem 7. In exercises 7 through 12, point P is on the terminal side of angle theta. Evaluate all the 6 trigonometric functions for theta. If the function is undefined, write undefined. Well, in this case, we are given, in the case of 6, the earlier problems 3 through 6, we're given a drawing. Here in 7, we are not. But we can, since we're given a coordinate pair, we can create a drawing. If we create a little coordinate pair here, we can put the point here, 3 over 3 to the right, 3 comma 4. So here's the point 3 comma 4, and we're trying to find the ratios. And to do that, let's just fill in what's left. We have our opposite side here. If this is theta, our opposite side is going to be 4. Our length right below the triangle is 3. And then the hypotenuse is going to be square root of 4 squared plus 3 squared, which equals square root of 25, which equals 5. So our hypotenuse is 5. So that's just going to be pretty easy. Our tangent is which we can get already. Tangent theta is going to be opposite over adjacent, which is going to be 4/3. And so cotangent is going to be reciprocal 4/3, which is 3/4. We're going to have sine theta. And the sine is going to be opposite over hypotenuse, so opposite over hypotenuse is going to be 4/5. And the cosecant theta is going to be reciprocal of 4/5, which is 5/4. And the cosine of theta is going to be adjacent over hypotenuse. And adjacent is 3, and hypotenuse is 5. So our secant is going to be equal to 5/3. Anyway, these are the 6 trigonometric functions or ratios here for problem 7. Problem 9, and again, we have a point at 0, 5. To do that, to find where that is, we draw a coordinate plane. Here's an x-axis, horizontal, y-axis, vertical. We have point 0, 5. We start here at 0, 0 at the origin, go up 1, 2, 3, 4, 5, and here's the point right here on the y-axis, 0, 5. Well, what's going to happen is we don't move left or right, so in this triangle, if we want to call it that, our adjacent side is going to be 0. All right, our opposite side is going to equal 5. And our hypotenuse is going to be, this length here will also be 5. So, to find tangent, all right, tangent is opposite over adjacent, which is going to be 5 over 0, and so tangent theta is what? Undefined. I'm going to abbreviate undef. And cotangent equals, so 5 over 0, we have 0 over 5, which equals 0. So that's going to be tangent, cotangent. Sine is going to be opposite over hypotenuse, okay, which is going to be 5 over 5, which equals 1. And cosecant is going to be the same thing, because cosecant is reciprocal. And the cosine is going to be our adjacent, which is 0, over our hypotenuse, which is 5, which equals 0, and our secant is equal to 5 over 0, which equals undefined. Undefined. Okay, that would be, just kind of box in all these things. There'll be 5 of them right here. And plus we have our, that'll be 4 of them. Okay, that is 4 of them. And then 2 more here. Actually, this top one is simplified to undefined. Okay. Problem 11. If point P is on the frontal side of angle theta, again, if we draw a coordinate plane, we have 5, comma, -2, so we go to the right 1, 2, 3, 4, 5, and down 2, and so our point is located right here. And to analyze it using trigonometry, we go straight to that point and have the right side of this triangle be available. And the point here is going to be -2, 5, or 5, -2 rather. I'm getting dyslexic here. 5, -2. So 5, -2. And -2 is going to be our opposite here, and our adjacent is going to be 5. And our hypotenuse is going to be square root of -2 squared plus 5 squared. And this is going to be the square root of 29. So square root of 29 is our hypotenuse. So our Adjacent, we'll do sine. Sine theta equals opposite, which is -2, over our hypotenuse is square root of 29, and rationalizing the denominator, if we divide the numerator and denominator, multiply the numerator and denominator by square root of 29, we're going to get -2 square root of 29 over 29. For the cosecant, we're going to get the reciprocal of -2 over square root of 29. So we're going to get negative square root of 29 over 2. And for the cosine, we're going to get adjacent, and our adjacent is 5 over the hypotenuse, which is square root of 29. And rationalizing the denominator, if we multiply the numerator and denominator by square root of 29, we're going to get 5 square root of 29 all over 29. All right, so let's see, I forgot one thing, didn't I? I forgot two things, actually. Okay, secant theta is going to be the reciprocal of cosine, and so we're going to have -29, square root of 29 over 5. The cotangent, tangent, tangent theta is going to be equal to our opposite, and our opposite is -2, and over adjacent is 5. So that's going to be it, just -2/5. We could decimalize it, make this -0.4. We could take, now we can find the cotangent theta. I take the reciprocal of tangent, so we're going to have 5 over -2, which is going to equal -2.5. So anyway, there's tangent and cotangent. Anyway, that's all these odd number problems in the set from 1 to 12. Go ahead and work all the other ones. Thanks.